In this video, we'll begin our discussion of vector fields. In this video, we'll focus on a two-dimensional vector field. We're going to sketch one by hand. If you haven't already, and I will post this in Blackboard, make sure you watch this video. This video is of, I think the channel, it's called 3 Blue, or 3 Brown, 1 Blue, or something like that. One of those. This is the person from Khan Academy that really, I think, began all of that. But anyways, he creates very beautiful animations. So check that video out. It's invaluable for this section. I cannot get across what he gets across with these animations with a sketch. We're still going to sketch by hand because I want to show you what that looks like. But that link up there is invaluable. Say it over and over. I think my understanding of vector fields became clearer with this video. All right, so here's a formal definition of a vector field. Let fg be defined. These are just functions on a region R of R2. So we're plugging x and y's into those. A vector field in R2 is a function f that assigns to each point in R a vector. So it would be a vector pointing at a point. The vector field is written, and then we have it written like that. It is a vector. Notice the bold f. So when we write it, we're going to write f with the arrow on top. And then we have two components, a function of f and a function of g, of x and y in each, named f and g. A vector field is continuous or differentiable in a field if f and g are continuous or differentiable. So if these functions here are continuous and differentiable, then the vector function is continuous and differentiable. Okay, let's get into sketching one of these things. You're not going to like doing this by hand. We're not going to do very much, and thankfully we're not even going to try to do it in 3 dimensions. All right, let's give this a shot. So what I like to start, let's look at the vector function and try to think about it. Okay, I got negative I and a 3yj. So notice that the j component, or y component, is variable, right? It changes when y changes. But our I component is a negative 1. So it's going to stay the same. So I'm just going to graph like a bunch of x's because I know it's going to change, and you'll get an idea. Let me show you what I mean. So I'm thinking I'm going to graph points on the x-axis. Let's start with 0 first. We'll do 0, 0. All right, a 0, 0 vector. When I plug 0 into this, I get negative 1. Nothing changes. And then I get a 0 there. So I go to 0, 0, and I'm going to plot a vector that goes 1. I'm going to get rid of the dot. A vector that goes across here and makes an arrow there. But notice, if I plug in, okay, let's plug in a different x, like let's do 1, 0. I also get negative 1, 0. Because the x doesn't actually change anything. So at this point, and I'm going to copy and paste because I'm going to make mine look uniform. Oops, as I change the size there. Right, it's going that way. Notice that if I put any variable, any number, I'm going to put a k there, 0, I'm going to get the vector negative 1, 0. That's for any x I pick. So that means along the x-axis, I'm going to have all these vectors pushing that way. So if you were sitting on the x-axis, you would get pushed to the left. And then we can just duplicate this because it's the same for any positive or negative. So you're going to copy them over. But we get vectors going across that way. So if I'm sitting on the x-axis, I'm getting pushed to the left. Whatever the units is, it's one at a time going that way, whatever that means. And we actually have vectors in between all these vectors too. We have a vector at every single point on here. Like you zoom into here, you zoom in all the way, we're going to have a vector right here, but we're also going to have a vector right there, right there, right there, right there. So there's a vector everywhere in this field. But we're only going to look at a few to get an idea of what the field looks like, or feels like, rather. All right, so I think I'm going to continue in this pattern. Oops. We know that the x doesn't change, so I'm going to leave x. Let's pick another number. We'll say k. And then let's do 1. So if I plug that in, I still get a negative 1. That didn't matter. But now the y component, if I plug in 1, is a 3. Now this is every y equals 1. That's along this line here, right? That's the x's are going to change along that line. But they're going to have a vector like this in every single spot along that line. So it's going to go over 1 and up 3. So I'm going up to, let me make sure I did that correctly. 1, 2, yep. And there's my arrow. So at that point, the vector field, all these forces, if we're talking about forces or fluid, could be a bunch of different things. Vector fields represent a whole lot of things, as you can see in the video. Alright, so I'm going to go, now I know this is the same all the way across, so I'm just going to put a bunch of, I could even do it like this. Now I'm going to copy and paste, so mine's going to be a little easier here. But we get all these vectors going across like that at each point that is 1. Right, they're a little above it, but let's see if I can get it down. There we go. Not the best, but we get the idea. Right on that axis. That's good enough. Right, so they're spitting out like that. We also have that on this side because that K can be a positive or a negative. So I'm going to put that over here. So out there, those vectors, if I'm at those points, these points here, it'll push me out that way. We also, oops, keep pushing the back button. We have those vectors. I'm struggling here. I'm just going to set it. There we go. Whatever. You get it. And then we also have vectors going down this way in that same manner. Right? Because if I were to let, we do K, -1, I'm going to get a -1, -3. So it would be this vector going in that way. So we can start seeing the picture here. It looks like it's some kind of like pushing everything out, and let's think about as we get further out away from the x-axis, we can see that the vectors are getting bigger, right? If I were to let f, and we know the k's don't matter, those are going to be the same, and I were to let it be, we did 1, what if we did 3? All right, all those vectors would look like this, -1, 9. I can't fit that on my page, but as you can tell, as I go up, that's just up to 3. Those vectors are going to become, like from here, would be very, not like that, but over 1 and then up 9. So it would be pushed out like that. I'm not going to try to sketch them all because everything's going to get bundled up, bunched up, and we're not going to get a clear picture. So this vector field pushes everything to the left, more direct if you're closer to the x-axis, but as you get away from the x-axis, it's going to push you further to the, it pushes you to the left still, but further out away from the x-axis. Again, these are very easy, much easier to see in a electronic grapher, so let's actually do that. So I'm going to go to, it's just GeoGebra. So if you Google GeoGebra vector fields, you'll get something like this. So I'm going to type this in. This is going to get us a feel of what we just graphed. I did -1 there. And then it was just 3y. So if I graph that thing, and the vector field, they're trying to do it to scale, which makes sense, right? So everything gets longer as we go out away, but it's pushing out away from the x-axis. Unless you're on the x-axis, then it just pushes you to the left.